Good morning, students. In the previous session, you had studied about the first principles method of finding the derivative. I had explained about that one, and when the function is the sum or the difference of the functions, how to find the derivative, or maybe product or the quotient, or when it is multiplied by a scalar. In today's session, I am going to give you the standard derivatives which you have already studied. Again, I am recalling whatever you learnt in first year PUC. In first PUC, you had studied one algebraic function and then the trigonometric function. So, let me give the formula to get the derivative of the functions which you already studied. Then exponential and logarithmic function which we need here, we will be finding the derivative of this function also. First, I will start with the algebraic function. So, that is the first one. Now, if n is a rational number, n is a rational number. What do you mean by rational number? Any number of the form p by q, where p and q are integers, q not equal to 0. So, when n is any rational number, then y is equal to x to the power n means the dy by dx, the derivative would be n into x to the power n minus 1. The derivation I am not doing because you already learned this one. So, it is n into x to the power. The index you write and decrease the index by 1. So, n into x to the power n minus 1. Now, suppose this is in the denominator position. It is 1 by x to the power n. Then it would be dy by dx would be equal to this index n you write in the numerator with the negative sign, minus n you write, then increase the index of the denominator by 1. Do not get confused. See, here it was in the numerator, it was decreased by 1, n into x to the power n minus 1. Sometimes it would be in the denominator position. Suppose it is a 1 mark question in some competitive examination, you need not take it to the numerator, apply the formula. If you use this result, if you remember this one, directly you can get the result, because for a 1 mark question, you have to solve it within half a minute or 1 minute. So, it is this index you write minus n, then in the denominator only increase the index by 1, that is x to the power n plus 1. So, this is the first formula we study. Now, as a particular case of this one, suppose n is equal to minus 1. What happens in that case now? It becomes 1 by x. This formula is applicable. According to this one, here what is the index of x here? 1. So, write it as minus 1. Now, increase the index by 1 of the denominator by 1, 1 plus 1, 2. So, wherever 1 by x is there, its derivative becomes minus 1 by x square. Now, as a particular case of this again, y is equal to root x. What do you mean by root x here? X to the power 1 by 2. So, it is a fraction, a rational number. So, what is the formula here? It is dy by dx is equal to 1 over 2 into root x. So, it is root x and the derivative becomes 1 by 2 root x. Now, here one thing I want to tell you, because in this second year's portion we will not be considering the simple function, we will be considering the composite function. Composite function you have studied in the first chapter, relation function, you have studied about that one. The composite function combination of two functions here. So, here we will be considering the composition of functions. 2 functions, 2, 3, 4 functions would be combined. So, this rule, generally you can remember, though x I have written here, anything raised to the power n, the derivative would be that index into that function to the power n minus 1. And any function under the radical sign would be 1 over 2 times the root of the same function. And 1 by x will always give 1 by any function minus 1 over square of that function. Like this, though we have calculated, derived it in the case of an algebraic function, you can use in general also. The same rule is applicable In the place of x, I am having e power x. So, e power x to the power n means n into e to the power x whole to the power n minus 1, like that we can write. So, these are the 3 formulae connected with the algebraic result. Next is trigonometric function. The fourth one, y is equal to sin x. There are 6 trigonometric ratios or functions. We will be calculating, I will be writing all the derivatives. So, if y is equal to sin x, then dy by dx would be equal to cos x. Of course, all these formulae we have derived in first year PUC using the first principles method. Here I am directly giving you the result because this has been done already in the first year PUC portion. Now, if y is equal to cos x, then dy by dx would be equal to, it is minus sin x. So, be careful about the sign. Now, y is equal to tan x, then dy by dx would be equal to secant square x. dy by dx is secant square x. Now, let me go to the other trigonometric function. Y is equal to cosecant x. I am taking the reciprocal ratios. Here we get a negative number. dy by dx is minus cosecant x into cot x. Similarly, y is equal to secant x means it is dy by dx equal to secant x into tan x. Here also we are getting a product. Lastly, y is equal to cot x means dy by dx would be equal to minus cosecant square x. Now, these are the 6 trigonometric functions we had considered in the first year PUC. So, here you observe 1, 2, 3. 3 are positive, 3 will be having the negative sign. So, sin x will become cos x will become minus sin x, tan x will have the derivative secant square x, cot x will have the derivative minus cosecant square x, and cosecant x has a derivative minus cosecant x into cot x, and secant x, the derivative of this is secant x into tan x. So, these are the trigonometric functions whose derivatives I have given you. Now, in the previous session, when I was considering the scalar multiplication, I told you k into fx. If the function is k into fx, then the derivative of this function would be k into d by dx of fx. That is, you have to keep k remains the same. When a function is multiplied by a constant, the constant remains the same, only the function has to be differentiated. Suppose we are having a function which is a constant function, y is equal to k, or y equal to fx equal to k. Again, you have studied about the constant function in the first year PUC relation in function. Y is equal to k, a constant here. In that case, no, the derivative would be 0. The reason is, when we increase, as I given the procedure in the previous session, we increase the value of x by delta x, y by delta y, etc. K being a constant, how do you define a constant? Which does not change its value. So, you cannot increase or you cannot decrease the value. When y plus delta y, this would be k. When y, this would be k, isn't it? Therefore, when you subtract, we get 0. When you divide by delta x, we get 0. When you take the limit also, you get 0. Therefore, when y is only a constant, purely a constant function, then the derivative is 0. And if it is given k into fx, then k remains the same, fx becomes f dash x. Be careful about this one, because I have seen many students committing the mistake here. Wherever k is there, they write the value 0. It is not so. If it is only a constant function, the derivative becomes 0. When it is multiplied by a function, the constant remains the same, the function has to be differentiated. So, these are the things which I learnt in first year PUC portion. Now, these are the 2 basic functions. Usually we consider algebraic, trigonometric, exponential and logarithmic function. These are taken as the basic function. Afterwards, now we will be combining them, which is called as the composite function. So, we have learnt about the algebraic as well as trigonometric function in the first year PUC. Now, two more functions. One is exponential function, the other one is the logarithmic function. Here, we use the first principles method to find the derivative of that one. Therefore, I am writing now the derivatives of exponential and logarithmic function. Exponential and logarithmic functions. Both of them. One by one I am considering. So, exponential function. Exponential function means it is e to the power x. One by one let us consider. So, here altogether you have taken about a 10 formula, that is y equal to x power n, 1 by x, root x and the constant function and the 6 trigonometric ratios. So, let me move on to the next one. Here I am considering fx to be equal to e to the power x. This is called as it's called the exponential function, e raised to the power x. E, I have told you while discussing about the logarithm, e is called as the exponential constant, which is an irrational number lies between 2 and 3. So, e to the power x is called as the exponential function. So, let me take fx to be equal to e to the power x. I am using the first principles method. Then, let me write, then what is x plus h here? Then f of x plus h would be e to the power x plus h. Now, let me come to the standard formula. We know that f dash x, that is what we are calculating using the first principles method. We know that f dash x equal to limit h tending to 0 of f of x plus h minus fx whole thing divided by h. This is the standard formula. If you want to calculate the derivative of any function, we use this formula, which is called as the first principles method. Okay. This is a general formula. But what is fx in this case? It is e to the power x. So, let me write this function, that is limit h tending to 0 of e to the power x plus h minus e to the power x whole thing divided by h. See, while giving the definition or the method of finding the derivative, I have taken only the general function. Here I am telling you, depending upon the function that we are considering, what are all the simplification we could do, we can do there. Now, the left hand side is f dash x, right hand side is limit h tending to 0 of, look here, I am using the law of the indices. It is of the form a to the power m plus n. The first law of the indices says that a to the power m into a to the power n is a to the power m plus n. So, a to the power m plus n is given, you can write it as a product. That means that you can split and write e to the power x into e to the power h minus e to the power x divided by h. Look here, we are taking the limit as h tending to 0. So, wherever h is there, the limit is applicable to that particular term. Now, this e power x now, which is free from x, which is free from h, the limit does not apply to that one. So, that can be taken as common factor. Take out e to the power x because it does not contain h. So, the limit is applicable wherever the function contains the term h there. So, e power x, which is a free term, can be taken outside. Write the remaining limit h tending to 0 of e power h minus 1 over h. Now, you can take the limit of this function. What is the limit? Say, I hope you remember that one. Before I started continuity, I had given some standard exponential limit also. That was limit e to the power x minus 1 over x as x tends to 0 is equal to 1. So, here in the place of x I am having h, that is the only difference. E power h, the same quantity is present and that is tending to 0. So, the value is 1. Therefore, what is the derivative here? F dash x is e to the power x. What was the function we started with? E power x. That means that this exponential function e power x remains the same even after differentiation. So, this is the procedure we adopt to using the first principles method to find the derivative of the function e to the power x. Now, after deriving, you have to take this with the remaining 10 formulae which I mentioned today. So, taking this, now totally all the formulae should be remembered by hearted properly. Now, I have taken e power x, e is the exponential constant. Now, I will take another function. Instead of e, I am taking a to the power x, but remember a should be a positive number. In this case, a should be a positive number. So, let y be equal to a to the power x, or you can write y is equal to fx. You can keep y also, no problem. Let y be equal to fx be equal to a to the power x. Then take it as result 1. To make use of the first principles method, the same procedure, f of x plus h would be a to the power x plus h. The same steps, the same law of the indices we are using here also. The difference is there it was e, here it is a. There it was an exponential constant, here some general constant, but it is a positive number. Now, take this result as 2 as usual, subtracting we write the value, need not give any number here because we are not using the procedure. Write it as f of x plus h equal to a power x plus h. Use the formula. Just now I wrote that one. It is limit h tending to 0 of a to the power x plus h. General formula first you have to write f of x plus h, etc. And here I am writing the particular function divided by h. Now, again it is of the form a to the power m plus n. So, applying the law of the indices, limit h tending to 0 of, write it as a product a power x into a to the power h minus a to the power x divided by h. Now, a power x which is free from h, the limit does not apply to that one. So, it can be taken outside the limit sign. So, write the remaining function, limit h tending to 0 of a to the power h minus 1 over h. Now, we have to take the limit of this one. Again this also I have given you, the formula is that one, limit x tending to 0 of a to the power x minus 1 over x would be equal to log a to base e. If that were to be e to the power x, then the value would be 1. Okay. And in the session about logarithm, I told you if these both the numbers are same, the value is 1. I had given it as a note, isn't it? So, here suppose in the place of a we had e, log a to base a, that is why we got 1 there in the previous problem. Now, it is log a to base a. So, here a to the power x into log a to base a. Now, this is the derivative of the function a to the power x. So, if it is the exponential function e power x, the derivative remains the same, it is e power x only. If it is a to the power x where a is a positive constant, then the derivative is a power x remains the same into log a to base e. So, it will be multiplied. Whatever, suppose it is 2 log 2 to base e, it is 100 log 100 to base e, like that you have to write the value. So, these are the derivatives of the exponential function. Now, let us see how we can calculate the derivative of the logarithmic function. Logarithmic function. Now, here logarithmic function means you have to be little bit careful. Let y be equal to fx be equal to log x to base e. I told you this is a correct method of writing. This number usually we write a little above this, like in this position. See, while working out problems, sometimes in the place of we are going to get a formula for this one. If the base is e, this formula is applicable. If the base is some other number, we have to use the law of the logarithm, rearrange the function, then only you can find the answer, find the derivative. So be careful, whatever formula you are going to derive is applicable only when the base is e, not otherwise. So let y equal to fx be equal to log x to base e. Now increase the value by h, the usual one. As whenever it is given, write it as x plus h. Wherever x is there, write it x plus h, log of x plus h to base e. Now let me use the formula. F dash x equal to limit h tending to 0 of f of x plus h, first term, that means log of x plus h to base e minus fx, that is log x to base e divided by h. See, depending upon this function, we will be using the appropriate rule. In the earlier two problems, e power x and a power x, no? I made use of the law of the logarithm. It was e to the power x plus h and a to the power x plus h. I had used the first law of logarithm, first law of indices, to write it as e to the power x into e to the power h, because we know that from the first law of indices, a to the power m into a to the power n is a to the power m plus n. Keeping the same base, we add the indices. Here it is of the form log m minus log n. In the chapter in the previous session, one of the previous sessions, where I discussed about the logarithm, the second law of logarithm, what does it say? The second law says that log m by n to base a is log m to base a minus log n to base a. I told at that time, the laws are applicable both ways. If it is given at the left hand side, you can write the right hand side. Suppose you come across an expression which resembles the right hand side, you can write the left hand side. That is what I am using here. Look here, it is log of something minus log of something. This is m, this is n we can take. How do you write this one? It has to be written in the form of a quotient, that is log of m by n. Log of m by n, m is x plus h and n means it is h. So I can write it as limit h tending to 0 of log of x plus h divided by x to the base e divided by h. Carefully you write. See, the number itself would be in the form of a quotient. Now in that part, split it. Limit h tending to 0 of log of x, both there are two terms here, divide by the denominator, x by x means 1, the other one is h by x, you can't do the simplification, to the base e divided by h. So each step I am doing only one calculation. First I took the function as f of x, then I wrote f of x plus h, I made use of the first principles formula method, the formula, and wrote it as limit h tending to 0 of f of x plus h minus f x divided by h. In this case, f x is a logarithmic function. Now, again, while giving the standard limits, I had given this one, limit x tending to 0 of log of 1 plus x to base e divided by x. The value is equal to 1. This is the standard logarithmic limit. So before I started continuity, all these standard limits were given. Algebraic and trigonometric limits you had studied in first PUC. The exponential logarithmic limits I had given before I started continuity. Now this is the one which is the standard logarithmic limit here. Now if this is in that form, say a log of 1 plus x, that x should be in the denominator, that x should tend to 0. Let us compare this with this one. See, we are having the same base e, 1 is also there, plus, see, in the place of x, I am having h by x. See, I told you whatever quantity x is there, the same should be present in the denominator also. So what is the difference here? 1 plus h by x, we are having only h here. How to get x in the denominator? divide the denominator by x. I am doing some adjustment, manipulation. But if you divide the denominator, what happens to the value? It gets changed. Therefore, you multiply. So, what I have done? I have multiplied and divided the denominator itself. See, we do this type of adjustments in many problems. That is why we say add and subtract. When you add something, subtract something so that the value remains the same. When you multiply by something, divide by the same thing so that the value remains the same. We can do this adjustment without changing the value of the function. So, here multiply and divide the denominator by x. Now, this x which does not contain the variable h which is tending to 0 here can be taken outside the limit sign. So, h is in the denominator position. Therefore, I can write it as f dash x equal to 1 by x into limit. Instead of h tending to 0, I can write h by x tends to 0. See, this is tending to 0 means 0 by x, that also tends to 0. So, what is that we are having? It is logarithm of 1 plus h by x to base e divided by h by x. Now, you observe that all the conditions have been satisfied. Same quantity is present here, base is e, it is log of 1 plus x form and that is tending to 0. So, what was the answer we had got here? As the limit, it was equal to 1. That means that f dash x equal to 1 by x. So, this formula we have to remember. So, log of x will be always having the derivative 1 by x. Log of anything would be 1 by thing. E to the power x will be e power x. E to the power sin x will be e to the power sin x, like that. So, though these basic functions we have derived here, we can apply in general when we have a composition of the functions. So, these are the 3 functions which I have learned in today's session. That is, we have calculated the derivative of 3 different functions. What are they? So, first 10 results already known to you. So, the 11th was if y is equal to e to the power x, then dy by dx will be e to the power x. Next, 12th result, if y is equal to a to the power x, then dy by dx would be equal to a to the power x into log a to base a. One thing you have to remember, a should be greater than 0. And the last one, it is y is equal to log x to base e, then the derivative dy by dx would be equal to 1 by x. If the base is not e, then you cannot use the result here. So, you have to be careful. So, 10 results already studied in the first year PUC. These 3 have done the derivation. So, these are the basic functions whose derivatives we have studied. Now, in the coming session, I will be working out some problems because to be familiar with all of them. See, in the first year PUC I studied about the algebra of derivatives, which in the previous session I gave you about that one. That is, when the function is sum of 2 functions, a product or quotient or scalar multiplication, how to find the derivative. Just to revise that one and just to be familiar with the formulae, I am going to work out some problems in the coming session. Afterwards, now we start this year's portion. Here we do not start with a simple function, we start with a composite function. That means it will be containing not one function, it will be a combination of 2 or more functions. So, problem would be how to find the derivative of a composite function. So, we will meet in the next session to solve some problems where we make use of this basic formula, the derivatives of the basic functions. Thank you.